So for today, we'll actually be solving some problems related to work. Now, there are actually three conditions for which work is done. The first one, uh, there must be a force present to do the work. Number two, the force must be able to move the object. And number three, uh, the motion of the object must be parallel to the force. No, again, parallel to the force, or like this. Otherwise, um, if the if the if the displacement is perpendicular to the force exerted, then no work will be done. Okay. However, if the force exerted is at an angle, right? Remember, I told you that there will be both a vertical component and a horizontal component to the force, and depending on the displacement, one of those components will be the one contributing to the work. So sample problem 1, we have a forklift in a warehouse which lifts 1,000 newtons of boxes 34 meters from the floor. Compute the work done by the forklift. Okay, so if you recall, work has two formulas now depending on how it is exerted. Okay, so the most basic formula for work would just be work is equal to force times distance. And if you notice, there is a symbol in between force and distance or displacement, and that is just another way of signifying multiplication of f dot d. But of course, you can also always just write work is equal to fd. No, they are the same thing for now. Okay, and then if this is, this is a simple force, no, exerted either vertically or horizontally. But what if the work is exerted at an angle, no, or rather the force, that the second formula would just be then F cosine theta times displacement. Okay, so please remember those two equations. All right, so first thing we need to do is to write all of the given using the GUS or GUS method. So given for in this case would be 1,000 Newton and then 34 meters, right? So look at the units, and the units will give you a clue what the quantity is. So 1,000 Newton is now obviously the force. So let's write that force is equal to 1,000 newtons. And then 34 meters, that would be the distance. Pero mas maganda if we use displacement. So 34 meters, because again, displacement takes note of the direction, right? Okay, so now we are supposed to look for the unknown, which is work, because it says here, compute the work done by the forklift. Okay. Unknown is work. And then to solve for that, you just need to use the formula, the first one, the simplest one, or the simpler one. So work is equal to force times displacement. This is just equal to 1,000. So I can write the unit or not. I can just skip it, but I make sure at the end when I write my final answer, I have my unit. Okay. So now we have 1,000 times 34. That's 34,000. We don't need a calculator for this. So that's work. And then recall that the unit for work is now the joule. Okay, joule. The symbol is J. And then just box your final answer. And then we are done with problem 1. Okay, so let me just write here the note. How come the unit became joule? It's because 1 joule, no, joule with the symbol J, is equal to 1 Newton meter. Okay? Where did I get Newton meter? The unit for force is the Newton, and the unit for displacement is meter. When you multiply them together, you get Newton meter, and 1 Newton meter is equal to 1 joule. Hence, the unit for work is the joule. Okay, I hope this is clear. So again, you can pause the video at any time if you want to, if you want to have more time to think about the solution. Okay. All right, let's now go to sample problem number 2. Let's see. All right. So sample problem number 2. If 60,000 joules of work was done on a rock which moved 25 meters, how much force was exerted? Okay, so you see here a picture of Yoda, now just to simulate the word problem. So you have a rock and a work was done on it, and that work was done vertically because the force was also exerted vertically, hence the rock moved vertically, now upward. Okay. Okay, so now let's write the given. So again, we have 60,000 joules of work and 25 meters. So just from the unit, you will be able to tell what that quantity is. So 60,000 would then be work, right? 60,000 joules. And then 25 meters, that would be the displacement, right? And for the unknown, so the question is how much force was exerted. So we are looking for the amount of force. So let's solve. No, again, recalling your pyramid, right? The pyramid to help you recall the formulas. So work would be on top, and then force and displacement at the bottom, right? So if we're looking for force, then by looking at the pyramid, the formula would be work divided by distance, okay, or displacement. So this would just be 60,000. Again, I can write the unit or not, divided by 25 meters, right? And then just getting your calculator, that would just be 2,400. And then since this is force, the unit for force is the Newton. Okay, don't forget. So final answer for sample problem number 2 is just this, no? So there's 2,400 newtons of force that was exerted in order to do 60,000 joules of work and to move the rock 25 meters vertically. Okay, so I hope this is clear. Let us now go to sample problem number 3. Okay. So sample problem number 3 is this. A box is being pulled by a rope which makes a 40-degree angle. Okay, so take note. Now we have a 43-degree angle. 40, sorry, not 43. 40-degree angle with the horizontal. No? With the horizontal. So that means the angle is measured from the floor. Okay? So if 30 newtons of force was applied and the box moved 12 meters, how much work was done to the box? Alright. So in this case, the word problem is not that simple. So to solve this, it's better if we illustrate or draw the problem just so we can imagine what's actually happening in the problem. Okay, so let me first draw the floor. Okay, and then we have the box right there. And then it says it's being pulled by a rope. Okay, so just imagine that there's a rope attached to the box, no, and then it's being pulled. So imagine this is the rope, right? It's being pulled. So it's the motion is like this, no? Take note of how I drew the arrowhead. The arrowhead is not going towards the box, but out, no, outward. kasi it's being pulled. And then this actually makes a 40-degree angle with the horizontal, no? With the horizontal. So we can pretend, we can put an imaginary line in here, no? And this would be parallel to the floor. So this is still horizontal. And then it says it makes a 40-degree angle. That 40-degree angle is this one. So let me just indicate that 40 degrees. Okay, and then this is the force. And then it says if 30 newtons of force was applied, so this force is actually equal to 30 newtons. And then the box moved 12 meters. So if this was the box, now after some time it would have moved horizontally. It will be somewhere here, somewhere to the right or to the left, but since we assume the force is this way, then the box will move to the right and it will move 12 meters. So that will be the displacement. So from its original position to its final position somewhere to the right, that would be 12 meters. All right. So if you understand the illustration, then we can begin to write all of the given. So the angle 40 degrees, I can just write that as Greek symbol theta, no? And I just put there 40 degrees. So don't forget the degree symbol as well. It's like a small letter O above the value for the angle. And then we have force equal to 30 newtons. Now again, newtons, so that's the unit for force. And then displacement will just be 12 meters. Okay, and then let's just write what the unknown is. The unknown is actually, the question is how much work was done. So work is the one that's missing. Okay, so let's solve. Again, recalling the formula. The formula for work is just force times distance, right? Or displacement. But there's an angle. So instead, we will use the formula F cosine theta times the displacement. Okay, so you're basically just multiplying everything, but this one, the COS or cos, actually stands for cosine. It's a trigonometric function. So you will actually be learning about this in grade 9 pa. But don't worry because your scientific calculator has the cosine function. So you just need to press on the COS symbol in your calculator so that you can get the cosine of any angle. Okay, so let's solve for this. Work is equal to F cosine theta times the displacement. Then we just substitute the values. So force is just 30. Let me put that in parentheses. And then cosine of what is the angle? The angle is 40 degrees, right? Let me just put that in a... Okay, and then lastly, we substitute the value for the displacement, which is 12. So again, I did not put the unit, but of course, you can always do so. Okay, so this will then just be, so on my calculator, I will just type or just click in 30 times, then I look for the cosine button in the calculator. So cosine, then 40 degrees times 12, and then that is supposed to give you the value of 275.78. No, I just rounded off to 2 decimal places. And then since this is work, I would have to put the unit joule. Okay, and then I'm done. So grade 8, please try this out. Check if you know how to compute for this using your scientific calculators. Okay, so try it out. If you don't get 275.78, that means you did something wrong, right? So again, to compute for this using your scientific calculator, it's just 30 times, then click on cosine, then 40, then times 12. You are supposed to get 275.78. All right? so moving on, let me move to the next slide. So please try solving these problems on your own, okay? So please pause this video and then work on it, work on these word problems, and I will be putting actually the solution to this on the next slide, right? So again, pause this video and work on these three problems. Okay, if you're ready, you can move to the next slide where we discuss the solution to all three problems. Okay, so let's have the first one. If it took a bulldozer 600 joules of work to push a mound of dirt 35 meters away, how much force did the bulldozer have to apply? All right, so this is the bulldozer, no? So it's a big machine in order to do this a big amount of work um, for lesser time, and also it's something that helps us humans to do our work much faster and much easier. Okay, so let's write the given. So 600 joules and 35 meters. So again, look at the unit so that you will know what quantity that is. So 600 joules is work, right? And then the bulldozer is able to push amount of dirt 35 meters away. So 35 meters is the displacement. Okay, so as you solve, it's always good to imagine the problem so that you will be able to understand it better. Okay, the unknown is force, because the question is, or the word problem is saying, how much force did the bulldozer have to apply? Force. So then let's write the solution. So the basic, well, let me draw the pyramid again, right? So work on top, force and displacement below, right? So since we're looking for force, that would just be work divided by displacement, right? So that's 600 joules divided by 35. Again, I can write the unit or not, but I just make sure at the end I have written my final unit. So force is now equal to 17.14 newtons of work, right? Or newtons of force, sorry, newtons of force. So I just rounded off again to 2 decimal places, right? Because in my calculator, there's a lot of digits still after 4. All right? So this is the solution to the try it out problem number 1. So again, you can pause this video at any time if you need more time to digest the material. Okay? So let me go to the next problem. Okay. So try it out problem number 2. You have this time a front end loader, and it's needed to apply 200 newtons of force to lift a rock. So rather, the front end loader needs to apply a 200 newton of force to lift a rock. So this is the front loader. A total of 275 joules of work was done. So the question is, how high was the rock lifted? So a front end loader is a machine that helps you to lift heavy objects, no, in great distances. So now let's write the given. So we have 200 newtons and 275 joules. Again, just looking at the unit gives us a clue about what that quantity is. So force is equal to 200 newtons, and then work is equal to 275 joules. And then the question is, so let's now go to the unknown. How high? How high was the rock lifted? So that tells you that you need to give a length, no? Length in this case would just be the displacement. Okay, so let's solve. Again, let me bring back the pyramid. So work on top, force and displacement below. So since we're looking for displacement, that will just be work divided by force. Okay, so that's just 275 divided by 200. Again, no unit uh, in the solution, but your final answer should have the unit. So 275 divided by 200, and that actually just gives me 1.375. So let me just write the whole thing. Meters, or that's approximately D equal to 1.38 meters, no? Rounding off to two decimal places. And then I just box my final answer. Okay? So it's easy, very much straightforward. All right. Let's now go to the final try it out problem. So in this case, you have a force of 75 Newton acting on a crane at a 30-degree angle. So this is similar to the sample problem that we worked on a while ago. This causes the crate to move 3.5 meters. So how much work is done on the crate? Okay. So this time you have a 30-degree angle now acting on a crate. So you can just imagine that to be something like this. So that would be the force. And then it's exerted on a certain angle along the horizontal. And this would be 30 degrees, right? And then it will move that way as well, no? A certain distance. And that distance is actually 3.5 meters. Okay, so let's write all of the given. We have 75 newtons, 30 degrees, 3.5 meters. So force is equal to 75 newtons. Again, just look at the unit. That will give you an idea what the quantity is. Theta, big letter theta, is 30 degrees, right? And then causes the plate to move. So that's the displacement, 3.5 meters. Okay. And then the unknown will just be work done. Okay, so let's solve. So again, the solution would be, or the formula to use would be the one with the cosine, remember? So work is equal to F cosine theta times D. Okay, so let me just write that again in here. And then I now just substitute 75, I put the parenthesis, times cosine of 30 degrees times the displacement of 3.5 meters. Okay, so again, look at this. This is not a problem because your calculator has the cosine function. Just look for the cos or cosine button. Okay, so just using your calculator, that would just be 75 times. Click on the cosine button, then 30. No need to put the degree symbol, times 3.5. Okay, and that will give us 227.33. Again, I'm rounding off to two decimal places, and the unit would be joules because this is work. And then I finally just box everything, box the final answer. Okay, and then my references are just this. Of course, we use your textbook, Practical Science 8 from Diwa Learning Systems. And then for the GIFs and images that are in this lesson, I just got them from gfeed.com and Google search. And then all of the audio files that I use are from bensound.com.